Hello, it is Sunday afternoon, almost dinner time, January 29th, 2023. We are back. I checked in to see if one of the other friends, one of the other avatars wanted to be here, but it seems like this is Tigger's project here, so he came back and we have a couple of things to talk about that have percolated since Friday night sewing event. This is where we had left off. We had our phase diagram. We had Shakti, Runner Girl, Wonder Woman. We had defined some processes, pathways to transition between phases. Vaporization, we call the sacred basic condensation, we call the Shavasana. And we also identified axis. Pressure might be energy, and the temperature axis might be labeled consciousness. There's like the next step, the next three things that came in. And it seems like significant that the washing machine is chugging along in the background there. So maybe it has something to do with this. And it does seem like this is like some type of portal that's open for, X number of hours or something. So, what, all this stuff comes through. We're going to put it in to this form here, and then the portal's going to close and it's going to be over. Nothing new will come in, no creative stuff. So it'll be what it is. So we're just honoring that. Next three things. One is I don't know if it's called enthalpy. I don't know if it's the exact thermodynamic term, but the heat of fusion, and we'll talk some about that. Then it came in to collect some data about this diagram, collect some more data for it. I'm not exactly sure how that works. And then, as any good science experiment, you need to run some experiments to see how well your model is validates against the real world. So how do we run experiments to validate this? I'm not sure. But the name came in. It's going to be called like the Pi Squared Project. Don't know why, but like that's the name that keeps popping in, the Pi Squared Project. So let's talk about heat of fusion. Alright, so I made a diagram down here. Here we go. So solids, so we have ice cubes. Here we have water. So ice cubes let's put it in a pan, a kettle. At school we use old big tin cans, whatever those big tin cans or metal cans are, because we put it on, use propane flames, we use all kinds of ways to heat this. So ice cubes in a can. Over here we got water in the can. The ice cubes have melted, and over here water is boiled off, or there's gas in the can. It's turned into water vapor. So the area that's most familiar with is if you put a pot of water on a stove and you start adding heat. They measure heat in joules here. So you start adding heat. As you add heat, 1 minute it's going to be a little bit warmer. Another minute it's going to be additional warmer. Another minute it's going to be warmer. So there's this linear curve to it, linear path to it. You add heat from the stove or whatever, the water heats up. Anyway, it's the part that we're familiar with easily. The science experiment we run in school for students is, get some ice from the ice machine, down in culinary or from the hallway, put it in a can, and measure the temperature, and it's 32 degrees. And then you turn the heat on, you start adding heat, and it doesn't go from ice cubes to liquid. You're adding heat, the temperature hasn't changed, it's still ice. Then it's like ice water, but the water's still at 32, So now you have some ice cubes and you have a little bit of liquid in there, but the temperature remains at 32. The temperature is not above 32 until all the ice is melted. But you've put in all this heat, takes 5-10 minutes of heating this container of ice before it turns into liquid. So this is called the heat of fusion. It's the heat that you have to put into the system, add to the ice cubes to change from one phase to another phase, from ice to liquid. So temperature hasn't changed. You added a whole bunch of heat, but you've changed the phase. And the same thing happens from liquid to a gas. You have to add a whole bunch of heat once you start your water boiling, right? 212 degrees Fahrenheit, 100 degrees Celsius. It's still, the water is still at that temperature while it's vaporizing, and you have gas, so you're not covering it, so then you get superheated, supercritical steam, whatever. So the thought is that right here kind of is like the runway that started this whole rabbit hole episode. You have to add a lot of heat. You have to add a lot of something to be on the runway to start at one end of the runway to get to the other end of the runway, where you now are in a different phase, mindset, psyche, or whatever. So, in our diagram, which we'll look at, from Wonder Woman to Runner Girl to Shakti, you have to add a whole bunch of something to get to the next phase, as well as coming back. You'd have to take out something. So I think we're going to scroll up, and it seems like it's important to scroll while this is going on, so I'm going to do it. I don't know why. Here's our diagram. All right, so here we go. We're saying to go one atmosphere, to go along this line from ice to water to vapor, we have to add a whole bunch of heat at these phase transitions from solid to liquid. You have to add a whole bunch of heat, whole bunch of something. So right at this phase line, the temperature doesn't change. It stays at 0 degrees C, although we're adding a tremendous amount of heat. So in our diagram, we've said, whether it's right or not, that this axis is consciousness. So somehow we're going to add a whole bunch of consciousness at this phase boundary to go from Wonder Woman to Runner Girl. We need to add a whole bunch of consciousness. To go from Runner Girl to Shakti at this phase boundary, we need to add a whole bunch of consciousness. No. In order to get consciousness to go, we need to add a whole bunch. Yeah. Let's rethink that. So, our consciousness is increasing, but at this phase boundary, whatever is going to increase our consciousness, whatever increases the temperature, which is the heat, what increases consciousness that we have to put a whole bunch into to get across that phase boundary. All right, I think what we have to do is we have to go down to the other. Now we've explained it here. We have to go to the other diagram because it won't line up when we do that on here. Okay, so we're saying to go from Wonder Woman to Runner Girl. I think I need to bring those images in just to keep my head straight. Hang on.